Hello everyone, welcome back. This is Managerial Economics. So this week we are going to go over Chapter 7 to finally talk about the productions of a firm. So when we talk about production, it's often the case that we thought about productions of physical product, but in this chapter we are going to talk about the general concept of productions in both the physical goods and services. So in this chapter, we're going to break down the production topics into several subsections. So we will first lay out what we mean by a production functions. So it's a mathematical representations of production costs. And then we would like to talk about different cases when the production take one variable input or multiple variable inputs and how the production can be optimized at the lowest cost or the lowest additional cost to produce one additional unit. And then we would like to also talk about how we are thinking on combining different resources or inputs to produce a product and how the costs associate with them. And finally, we're going to measure the efficiency of production process and also talk about the return to scales. So generally speaking, in a more in-depth or advanced economic classes, you are going to see a production function that it's looking like this one that we're presenting. It's not a terrible or a complicated production function that you're looking at right now. It's what we call a Cobb-Douglas production functions that has the characteristics that we are going to discuss about the costs associated with productions in general. But the general idea is if we think about the world in a simple sense, where the production usually will take into account of people producing the goods and also the capitals, like for example, the machineries or other physical inputs to produce a product or maybe service. Then L in this equation basically represent all the labor resources that goes into the productions, and K represent all the capitals associated with the productions. And the A term in this case, it's basically referring to any technological factors or improvements over time. And Q, of course, refers to the quantity of outputs that a firm can actually get returns from those inputs of labor and capitals. Given a very simple example from the book, you can refer to the case where a productions might needs to take both the L, which is the number of workers in this case, and K, which is the physical capital inputs. When the number of labor increase, in most cases, we are expecting the number of output to be increasing. And as well, for capital input as well, we are expecting the more physical input we put into a productions, we are getting more outputs in return. But if you look at this table carefully, the cross of the two input, let's say, well, looking at, we have number of workers, 6, combining with 1,000 units of capital inputs, we get 62 units of output return. As we increase the number of capital and labor, we are going to see the number of output to increase in this table. But the rate of change from a lower number of worker or lower numbers of inputs moving to a higher number, the increase of output seems to slow down as we are reaching to some level of these two types of inputs combined. So the number increase faster when we are having a lower number of labor and capitals as comparing to if we already have like many workers and physical capital to be used in the productions. So how is that possible, right? So you might actually want to ask the questions. If we have 5 people working today in the manufacturers versus if we have 10 people working in the same manufacturer tomorrow, we should have doubled our outputs from the production standpoint. But how come we don't see that particular ratios in this table? Is this table telling something wrong, or is there something that we are missing here? So before we get to that answer, we would like to first lay out some of the economic terminologies so that we can have some common grounds to talk about the production side of things. In general, we are defining the production input into 2 particular terms. One is called the fixed inputs, which is the types of production inputs that is not going to change when we decide to produce the more or less of the outputs in our productions. So you can think about things like the size of the factories or the machineries that we rent or purchase in a particular point of time, or maybe a set of computer that we use to monitor our productions. So those are sometimes be fixed regardless. We're producing, let's say, 5 cars versus 20 cars in one day. On the other hand, there are some variable inputs that we also define in economics. And those are the inputs that actually needs to be changed in order to produce either more or less of the outputs in the productions. So in general, you can refer to something like labor, right? So if we are planning on producing 20 more cars tomorrow in the same manufacturer, we probably need to have more people involved in the same day of production in order to get that many cars to be done. So those are what we call variable inputs. Again, they are not limited to labor inputs. They can be referred to something like ties, right? So, or maybe bodies of materials inputs for the cars. So if we are going to produce more car, of course, we are going to need more tires, need more body parts, need more screws, etc., etc. So those are what we consider to be the variable inputs in the productions. Now, if we have an idea about the fixed input and variable inputs in general, then we can talk about what we mean by short-run and long-run productions. So generally speaking, when we talk about short-run productions, we are referring to a production period where things cannot be easily changed. And in that sense, the most of the production's inputs will be fixed at that particular period of time. On the other hand, when we are talking about long-run productions, so business and firm, they will be thinking about all the things can be flexible and change and adjustable. And therefore, in the long-run productions, we are thinking all the resources employed in the productions can be varied or adjust, including the size of factories, including the number of machinery used. In those cases, when we are thinking about like different locations or maybe having one more factory plans in 5 years' time, those are the long-run production decisions that the firm is making, versus in the short runs, there has to be some forms of fixed inputs in the productions that which constraining the production's scales in that particular point of time. Here's another production table here that we can refer to the concepts. So on the first column is the number of workers in this production to produce a product, which is the Deep Creek Mining Company. And the second column talk about the total product, which is the total number of outputs that we are getting out from those workers in these productions. The third columns represent the marginal product of labor. So generally speaking, what we mean by marginal product of labor, we are asking the questions by increasing one more additional marginal number of worker, how many additional units of output we are getting out. So if you look at row number 3 changing to row number 4, so from 2 workers to 3 workers, we see the total output change from 16 to 29, and therefore the change from 2 workers to 3 workers will increase the number of output by 13 units. On the other hand, we also measure what we call the average product of labor, which is column 4. So the average product, it's using the number of outputs divided by the number of labor so that we can get a sense of how many units we are getting out from the worker productions from each worker on average at different production points in this outputs. And finally, we also apply the elasticity concept here in the production standards, which is what we call the production elasticity. In this case, we associate with labor. So the idea here is to use the marginal product of labor divided by the average product of labor. And therefore, we are getting the elasticity sense, how flexible or how sensitive the change of number of workers to the change of the outputs in the productions. So when the number is over 1, obviously we know that that's what we call a elastic part of the productions. When the number is lower than 1, or between 0 and 1, then we know is inelastic. So that means, well, increasing many workers might not be able to boost our productions by much. And of course, this term can get to the negative sides of things. That means, well, when the additional units are actually decreasing when we are adding more worker in the productions. So here are some mathematical notations that we use to present those concepts here. Again, the main calculations that you will be doing in this exercise is the marginal product calculations and the average product calculations. So the marginal product of labor is using the change of quantity output between two selections of labor input divided by the change of labor. So for example, if we are changing from 5 workers to 10 workers, then the change of labor will be 10 minus 5. And during that period, when we are changing from 5 workers to 10 workers, the output changed from 100 units to 150 units. So therefore, we use 150 minus 100, and we will get the change of quantity of outputs. And the average product basically using the total outputs at a particular point divided by the total number of workers at that point of time. And here is a simple plots that actually give you an idea related to the behavior of those marginal products, average product and total products in the production standpoint. So when we are looking at this plot, we notice that the marginal product of labor increase at first and then it starts decreasing. Same for the average product and as well as the total product as well. So you might want to actually think about this plot and associate with the questions we had before. Remember, we have a questions from a table seeing that, well, increasing the number of workers or maybe physical capital combinations, we don't see the number of output to increase by the same amount or same level scaled as the outputs level at the beginning. So why was that? Most of the time we can explain this by using the concept of diminishing marginal returns from productions. So is a concept that help us to think about the reality where more production inputs is pairing up with a fixed input in the productions, we might actually see the increase of production outputs in general. However, at some point, we are basically limited by those fixed inputs in the productions. For example, if we have a plant size that is maybe 1,000 square feet, and usually it fits 20 people working in that particular factory plant. But if we are trying to increase the output by putting 50 people or maybe 100 people into the same size of the plant, you can easily think about those people are not going to be able to work effectively or efficiently. And as a result, the total number of output per worker might actually decrease by hiring more and more. So there always will be an optimal point where the number of workers should be hired, but not slowing down other people working in the same factory plants. And this plot right here basically demonstrates that relationships. So the marginal product labor usually will peak out at some point and then start decreasing. But it's okay because, well, what we care so much about in the production is the total number of product produced or the output. And that associated with the total product curve on top of everything. And when is the total product curve is going to be optimized? Well, you can actually look at worker number 8. So where the marginal product is hitting almost zeros, then you know the next worker hire will definitely be producing less than the previous 8 workers. As a result, the total product in this case will start decreasing after the 8th workers. So the key of concept to pick up here is when we look at the production standpoint, we're always trying to figure out the marginal products in the productions so that we can find the optimal level of output to produce in a particular productions so that we can not make wrong decisions to continue to employ more production inputs to slow down the productions and end up producing less for the company at a higher cost, right? So again, we're back to the economic concept here, right? So remember the law that we associate this behavior is called the law of diminishing marginal returns. So when the initial productions applying the same or smaller amounts of production inputs, we usually see increasing the inputs will have a positive effect to increase the outputs faster. But at some point, you are going to see the productions to slow down a little bit by hiring one additional worker. And at some point, you might even see a decline of total productions when we are employing too many people, which is what we call the crowded effects. So here's a case study where we have observed from Boeing, which is one of the largest aircraft producers in the world, when they were planning their productions in Everett, Washington State, which is one of the largest building in the world. When Boeing starts rising the production from 244 aircraft to 560, the plants went into 3 shifts and twice as many parts pouring into the same factory plant. So you can see all this variable input has increased dramatically, but the thing is they are bound by the limitations of the factory plants. And as a result, they are resulting in a lot of the production scheduling issues, running shortage on some of the parts and slowing down the production process. And losing a lot of money in those poor planning operations. End up Boeing adopt to what we call a lean productions techniques, and they start cutting order size and they are start outsourcing some of the assembled parts work to other vendors. and adopting what we call the just-in-time ordering, which is a very sophisticated production process to manage their production so that they are not overcrowding the resources at the factories. So that has saved them a lot of money in that particular cases. Well, we talk about the marginal returns from productions. It's often the case we see those diminishing marginal returns, and obviously it's not a mathematical so-called theorems that it's always true, because there are some exceptional case where we might see the diminishing returns to be not captured in some of the real world cases. Think about Microsoft and Apple's. When they are producing their products or services, like Apple iPhone, Microsoft Offices, so those are the products that require a lot of money to develop. However, in the long run, as we see the markets to adapt to those products, and the market share has become bigger, more developer comes in to develop apps for, let's say, Apple iPhones, and developing some debugging or maybe additional packages for Microsoft Offices, and those values are being added to those products with no cost at all. Right, so in those cases, we see what we call a network effect. When a product becomes so popular or so adopted in the markets, it becomes easier for other contributor to add value to the product, so that it actually has a quality increase without the original producer putting millions and millions of dollars to add those quality to the products, and this is literally against the law of diminishing returns, right? Because, well, now the product, it's actually getting better, but no producers is paying more in costs to add those value to it. This not only just apply to a technology products like iPhone or Microsoft Office, but it also associated with a physical product like cars. You can think about network effects with car is like a dealerships, right? So when we have more dealerships of a particular brands, people adopted to the brands, and the car manufacturers start offering like warranties, services, service centers, so that people can actually utilize those additional services, and adopting more, buying more of those brands. This is also a network effect that actually reducing the cost to doing marketing promotions, because those services provided at a network levels, right? So it's no additional cost most of the time, right? So it's just an office setup, and then, well, they provide the service to the customer, and customers start gaining confidence on the brand, and they are buying more. So those cases, it's also a network effect that reduce the marketing and promotion costs for car manufacturers, in order to gain confidence or brand quality to the markets. So this is basically another visualizations that helps you to understand how the network effects influences the adoptions and potential buyers in the future. So as the market share on the x-axis increase, you will see those future adoptions probability will start also rising, but they're not rising at a decreasing rate, right? Because if they are rising at a decreasing rate, then obviously we hit the marginal returns. But we are seeing from the market share, let's say 30% to 85%, we are actually continue to see that adoptions to increase in the market. So this is basically another illustrations of against the diminishing returns behavior in the markets setups. So producing physical product, of course, it's a little bit easier to understand, but sometimes you might also want to think about in the modern economy, a lot of the money that we spend are not on physical product, but they are whether on informations or services. So there are some fundamental difference between selling a product versus a informations in the market. So, for example, when things are sold, seller cease to own, but the seller of information can sell again, right? So, informations can be resold in the market. That is very different because, well, those informations will not be utilized in a way that deprecates right into nothing. It's always relevant, right, to other people. Things exist in one locations and information can exist in many locations, right? So physical products can only be sold or sold in a physical locations where information can be fluent, floating in many different things or channels or platforms. Productions and marketing of things are subject to diminishing return. The marketing and also sometimes maybe the productions of information is subject to increasing returns. So it's a very different way of thinking productions of informations where informations it's usually involves some very small amounts of fixed costs and the incremental costs are very, very small, right? So you're not going to recreate the information by putting out a lot of cost to associate with it. Things involved in economies of massive scale in production information it's often produced by small firms at low costs, partly because of the network effect. Again, we back to the case where network effects will help the smaller firm to take economy of scales on producing informations in the market for values. Things focus on supply side thinking, high cost of distributions. Information products focus on demand side thinking and have almost no cost of distributions. So moving physical good from one place, one location to another location to the customer, distributing it to the door, it's expensive. However, distributing information is very, very low cost. And therefore, most of the time when we are thinking about selling informations in the market, we often think about whether there is a market demand for the information because that will mainly determine whether the business is viable or not. So since we are on the topic of diminishing returns, so we want to associate a little bit on the diminishing returns to the to this visualizations here. Just again, pretty much demonstrates the concept we have seen before. So this is like a more general cases where we have the diminishing returns from the marginal product curve increasing at the beginning and then start decreasing. When the marginal product curve is increasing before hitting the average product curve, we are seeing the total product curve to increase monotonically. And as a result, we call this the increasing return stage of productions. However, when the increase starts to slow down, which is where the marginal product starts to decrease, then we know hiring one additional worker will not get more productive than the previous worker hired. And as a result, we call this a decreasing returns production periods. But which is still okay because the total product is still increasing at that particular period of time. But when we get to the point where the marginal product goes under zero, so going to the negative sides of things, then we know anything beyond that area is called the negative returns. So by hiring one more person or maybe one more capital, it's going to produce less output for the firm. And therefore, in this stage 3, it's usually the point where we don't have firms producing their goods at that point of the productions periods. So you can think about decision making of resources allocation. It's pretty much tie with this concept here, right? So when we are thinking as a manager, how many people we should be hiring, it's always associated with the marginal product of that workers. It's important concept and it's very, very general concepts that you should always keep in mind. So how to find an optimal use of variable inputs? So as we demonstrate before, we always try to find the optimal level of output when the total product curve reaching the peak, or maybe the marginal product curve reaching the peak. So to think about that concept and then apply to firm's cost, we probably want to add a little more monotonical terms into our discussions here. So instead of talking about the number of units produced, we probably want to think about, well, if we produce that many units, what is the additional revenue we are getting from selling that unit? And also, what is the additional cost associated with the unit produced? And therefore, we can actually use what we call the marginal revenue product and marginal factor cost to associate with the monetary terms in the productions. So the general calculations here that we do is think about the change of total revenues in the business divided by the change of labor hire in the business. And that's basically the term we call marginal revenue product. If we talk about labor specific, we are using the term marginal revenue product of labor. We want to think about this marginal revenue product as a additional value added by hiring one more persons in the company. So what is the cost associated with that labor? Then we calculate what we call the marginal factor cost of labor. So we use the total cost to produce the product at the specific stage or period, and then we divide it by the total number of workers that involve in that particular stage of productions. And then we will get the change of total cost divided by change of total labor, and we get the marginal additional cost associated with hiring one additional labor. So given the marginal revenue product and marginal factor cost, we can compute the optimal amount of variable inputs. And the rule of thumb here is we're using the marginal analysis in chapter 2, where the additional benefits equals to the additional cost, and that's the point of optimizations we are looking at. So again, to look at this mathematical representations, where the short-run production decisions will always be optimized, where the marginal revenue product of labor is equal to the marginal product of marginal factor cost of the labors associated in the productions. Here again is a table that demonstrates. The first few columns are what we have seen, right? So the total number of workers, the total products, the marginal products. Now we have column 4 and 5 calculating the total revenues and the marginal revenues of the firm. The last two columns calculates the marginal revenue product of labor and the marginal factor cost of labor. And you want to find the point where the MRP equals to MFC, so which is at the 6th worker. So when the firm is going to optimize or maximizing the profits in this operation, it's when the firm hiring just 6 people, but not 7, not 5, right? Exactly 6. And that's basically the point where the firm will see the optimized profits from these operations. So far, we talk about just workers, right? So labor involved in the productions. But unfortunately, right, the world, it's a little bit more complicated than we thought. And often case, we are going to expect to see capital and labor to be used or applied in the productions at the same time. So in order to actually get a more in-depth analysis in our production cost topics, we might want to associate what we call the marginal rate of technical substitutions, which is one of the most fundamental economic concepts that help us to understand what would be a good ratios of the capital and labor to optimize our profits in the firm's standards. So the marginal rate of technical substitution is calculated by using the change of capital units divided by the change of labor. The allocation or allocated efficiency, technical efficiency, and overall production efficiency, they're all measuring the efficiency of a productions in different terms. So those allocation efficiency, it's usually what we refer to the least cost involved in the productions, right? So can we get the right amounts of inputs for producing a level of outputs desired in the business? Technical efficiency is associated with the maximum potential output given by the mix of inputs in a process. And the overall production efficiency, of course, is measuring by the two kinds, right? So we're balancing, well, what would be the least cost and what would be the optimal amounts with a associated inputs. So by balancing the two, we can actually get the overall production efficiency calculated. And finally, the book actually has several topics talk about all these different measures of efficiencies and also technicality on switching, substituting labor with capital, or capital with labor. But those are more advanced topics. So we're basically just wave hand to them and just put them in a very brief discussions here. But there's one more thing that it's actually important for most of us to keep in mind, right? It's other than the short run production cost concepts, right? So we see the marginal diminishing marginal returns. We see the cost associated with the additional labor or additional inputs. We also want to think about in the long runs. Remember, everything can be adjusted, right? So if in the short runs we are bound by the constraint of a particular firm's size or maybe a factory plan scales, we can think about in the long runs, the firm can actually have two factory plants next to each other, or maybe building one more in a new locations. And the scale of the production will increase dramatically in those sense. And you might want to think about when that happens, do we still bound by those constraints in the short runs, right? Where the size of the firm is fixed, right? So we cannot change it. But now in the long run, we're not. Are we still getting the benefits, right? To lower the cost to produce more goods in the long runs? And that will depend on what we call the return to scales concept. So return to scale is a concept that helps us to think about the long run productions of the firm when the firm starts to thinking about scaling up the productions. Right? So having one locations might be limiting our business opportunity. So having two location stores, maybe three or multiples, increase the scales of the business might help to increase the size of the markets and as well as lowering the cost, because some of this business methods can be applied to the same store, and some of these resources like people, training new people, or maybe having the same delivery car for a convenience store to deliver the goods to different places. Those can be sure. So the size of the scale will help reducing costs, but not always, just like the diminishing returns in the short runs. When scaling up the business, we usually will see what we call a increasing return to scale, where increasing 1% more of production inputs overall, we'll see an increase of more than 1% of outputs. But there are some cases when the firm is getting too large, they might see a constant return to scale, so they don't have any advantages on increasing the scale to lower the cost. But even worse, when the firm is growing too large, then they might actually find some of this managerial costs or associated costs to manage or to network those locations might be high. So as a result, they might see the cost to rise dramatically. And therefore, they are entering what we call a decreasing return to scale, right? They put more resources in there, but then they are getting less out of it. So those situations happens in the real world. You can think about the recent years where merchants like Macy's, right, or maybe Sears, or maybe some of the larger retailers out there, they're scaling up too much, right? So they have too many stores to manage, and they have a very expensive cost to operate those stores across the country, and as a result, they have to close down some of them, or maybe scaling back down, or maybe sometimes they might even file a bankruptcy. So all of this are very brief idea and concept associated with the productions and the cost side of the productions. There are a lot more that you can actually read from the textbook, and I strongly recommend you to look at some of the examples in the textbook and try to relate. So if you do have any questions, feel free to put it on the discussions. And if not, then I will see you guys next time.